Okay. So tonight we're going to do robot explorations for a couple of the Open Alliance teams. I talked to the coaches of both these teams, and they said we could do it and publish it. And so that's fun. And we can kind of look at what they're both building and how they're playing and how they're planning to play the game Reefscape this season. I don't think either of these robots are fully built yet by any means, so there's still going to be a lot of changes as they go to build the real ones. But we're going to look at 5406 Celt-X and 694 StuyPulse and see how they are going to kind of tackle some of the challenges in different ways than we did. But it's also good to kind of get an idea of what we expect when we're looking at like scouting robots when we're at other competitions. You can kind of understand some of how the mechanisms are going to break down and how some of the robots are going to kind of perform their actions and things. All right, so we can get started with Celt-X first. We're just kind of, as you look at the robot, there's some general things you'd be able to tell. You can just see in the corners, it has swerve modules. If we can get to the point where you can identify what the modules are, that's pretty nice, but not super necessary. These ones are MK4Is. They look like the ones we use. You know what those are. We have them on every robot we've built for the last like 3 years. Similarly, we can start telling that there's an elevator. Sometimes you have to count how many stages there are. Most of the time when we're saying how many stages an elevator is, we mean how many moving stages there are. So there's always going to be like an outer bar that doesn't move, just like we have. We have our stationary, which we sometimes call the stationary stage. But when we say like the robot we are building has a single stage elevator, there's only one up and down part of the elevator. This one looks like it has two. So it has this outer one here, and then the inner full-size stage here. It doesn't look like there's any sort of smaller carriage riding through it. We can see if their on-shape is set up for motion. It is. So yeah, you can see it all move. And so we get their intermediate stage here, and then what is sometimes called the carriage, or just in this case, the second stage. Since it is full size, it's not like riding fully inside this other stage. This would be a two-stage elevator. And so they're using this to get the height needed to be able to score level 4 coral. So the coral is going to come in here, and they have this single wheel here that's just going to spit it out onto the different level reef branches. Okay, so we have in addition to that, they have an arm riding on this elevator as well. And so it's designed to hold algae. And so it's able to flip down or over the top to kind of get out of the way if it needs to, so they can hold the algae like up above them if they want to be driving around with it. It might be possible that might be the location they're going to score it into. So it's very possible that when they go to score algae, I would guess that they're going to flip this over. Okay, it worked. And so this is probably how they're going to score algae. It's like over the back of their robot going that way. And then when they want to actually like pull it off the reef, they're just going to grab it using the arm this way. So they can kind of leave this down. Most of the time, I think they'll be able to leave it down under their scoring mechanism. If it wants to move again. Oh, it's still loading. All right, I made it load too much. I moved it around too much. All right, so they should be able to leave it kind of in a downward lower position. Yeah, something like that. And they can still move it up and down. Score coral however they need. In addition, they have a funnel. It is a powered funnel. So back here, they have a motor and a belt path down here, so that when they back into the human player station, the human player can slide the coral down, and then these belts will help drive it forward into their actual manipulator. They have a relatively decently wide manipulation range, so it's like 14 inches across there. The coral's 4.5, so they have about 3 widths of coral that they're able to like slide in there. That should be pretty reasonable for a human player to do that. I'm kind of jumping around a little bit just as I notice stuff, because again, this is the first time I'm really looking at this CAD. It is a cascade elevator. And so we can tell that because it has this single run of chain here, and then there's like a different thing over here. So it's not like a single continuous run of belt or cable. And so because we have these two distinct loops, that's normally a dead giveaway that you're dealing with a cascade setup. So this chain run is going to be powered down here in the bottom somewhere. And so we can see that from this gearbox here is powering that chain run. It looks like it's getting mounted somewhere in there. Yeah, so it looks like that little plate is going to mount the chain there. And so then as the elevator moves up, this stage is going to be powered by the chain. And the second stage is going to be cascaded off of that, where it's just powered by this round cord here, going over a pulley here and a pulley up at the top. And I think they have some way, I think they're using these to like tension the cords correctly. So like each end of this is going to like run into here or something along those lines, I think is how that works. And then this will get mounted somewhere to the other moving stage. Not entirely sure where that happens. It should be mounting somewhere in here. It should be basically like one of the fixed spots should mount to this bar so it can lift it up and down. And the other fixed spot is going to be mounted maybe to like this plate, something like that. Maybe not that plate. Could be something else. But it needs to be mounted to something stationary to the ground so that like difference in that motion is what lifts the other stage up into the air. And that kind of works for any of the Cascade elevators. We've seen a few in our different design explorations. I think this is their plan for their cable chain. It'll run up. They'll basically run wires up this, run it down through this pulley, and then on to their moving elevator stage. And then this is probably going to be, yeah, this is constant force springed. That's what this little coil is down here. Sometimes the CAD doesn't look like what it will look like in real life, but you can kind of tell it has the little tab, which is a dead giveaway to that being a constant force spring, kind of like a tape measure. When you unravel it, it's always wanting to pull back with the same amount of force. And so that's going to be mounted somewhere stationary. So as the elevator sort of pulls this up, this is always pulling the loop down and keeping it from getting like caught under the elevator stages or anything else. It's always trying to keep the cables away, which is very important. Anytime you have multiple stage elevators, it's really easy to get your cables caught or pinched by some of the stages. And that's a big no-no, as that can ruin matches and seasons if you don't do the wiring geometry correctly. But versions like this have been done before. I think from their build blog, they said they've done this same thing before. And that's one of the things normally pretty good for teams, is if you just are doing something you've done before and you know it works and you can implement it the same way, you're normally in a pretty good state. Even if the first time some other team might do it, it might mess up a little bit, you've probably worked out some of those issues with that same solution, and you can repeat it. So that's why we do a lot of that same thing. If we've done a certain type of dead axle shaft before, we'll do it again for rollers or for whatever other mechanism things we want to do. We'll try to repeat those over and over again and learn from our past stuff and build on it as much as we can to make robust systems. Let's see, what else do they see that's interesting? So they have handles built into their swerve modules, which is interesting, so that keeps them kind of out of the way. So they just go straight over the top of their swerve modules. And then they have some protective covers to make sure things don't fall in. And then their bumper mounts themselves seem like they're going to mount to their swerve plates as well. Or some part of their swerve plate, I guess something above their swerve plate. Oh yeah, so it's built into kind of this plate that's mounted on top of their actual MK4i plate, which is interesting. So they basically like added a third swerve plate. Oops, that's not the one I wanted to unhide. Keep going. All right, let me see if I can hide bumpers. There we go. Okay, so yeah, so this is their bumper mounting kind of rail. They have this bit of sheet metal here. It is going around the full U. So they're doing two-piece bumpers with the full sheet metal backing here. And so this will be screwed into whatever their backer is. This year, we don't know. It could be wood. It could be anything. Bumper rules are all open this year, so we'll have a lot of those changes. We'll see a lot more teams with different looking and style bumpers this year than we've ever seen before. Yeah, so right here they have this extra third plate that kind of mimics this plate and lets them do bumper mounting, handles, and some other stuff in a space that you're not really using otherwise. So this is pretty cool and would fit into some of what we're doing, but we basically have our top rail of the drivetrain in this same sort of capacity here. It's just one running around the whole thing, so we can mount other stuff there too without having to get as low for some of the other mounting. All right, what else do they have going on? We looked at their algae mech. Yeah, so algae and climber are relatively simple. It looks like they have 2 motors, so they don't have to do a reverse, so they just have a Neo here on one wheel and a Neo on the other wheel for their algae holder. So they're not having to figure out how to like belt around and do the gears for reversal or anything. And so that works. It's pretty easy to do. And then you just have a single motor here driving their coral deployment and a single motor out here to do the actual arm pivot. So that's all the stuff that's going up the elevator. So they have 4 motors going up the elevator. And so that's what all those wires are for. It doesn't look like they have Spark Max wiring or mounting on the elevator, at least not in CAD. So they may be doing the Spark Maxes down low and sending all of it up, but that seems odd. There's probably Spark Maxes somewhere in here, I would guess, just so you're not having to send the encoder cable the whole way, but they might be. It's very possible to send all 3 wires from the motor and the encoder cable all the way down. That's just a lot of wires to run all the way down instead of just having to run CAN and your power wires to each of the Spark Maxes. So it just kind of depends on how they want to do it. Both ways can work. What else do we do? As you're looking at other teams' elevators, one of the things you start looking at is like what their elevator blocks look like or what type of elevator blocks they have. These ones look like either custom or Thrifty Bot or modeled after Thrifty Bot. We can normally look. Yeah, it just says sliding bearing block plate, so this might be Thrifty Bot. I'm not sure. The part number is not there in the CAD, so they might be making versions of them, but they're pretty similar to the Thrifty Bot ones that exist for that elevator kit. So they might have made their own based on those or something like that. Okay. I think that's most of their scoring mechanisms, and so we can kind of look at their climber. They do have some interesting electronic stuff for their swerve, so they can connect motors and things and can. So they have some 3D printed parts that they add in to be able to hold all of their wires and organize that stuff pretty nicely. They do that on each of their modules. And they do get their battery back here to the side of their climber just to keep weight back when they're going to bring that in. What are we missing here? So there's a servo here, and I'm not 100% sure what that does right now. At one point, oh, I think I do know what that does. So this holds the servo is going to hold this in, like their whole pivot or the whole funnel. And then that's what this shaft is this is some sort of door hinge, basically, that's going to allow this whole funnel mechanism to swing out. It doesn't, oh yeah, there it goes. All right, cool, it doesn't in CAD. Okay, so this is gonna swing out and make room for their climb. How it's gonna do that, I don't know. It doesn't look like it's in CAD at the moment, or I just can't see it. It might be sprung. Springs would make the most sense. So if you just have it sprung open, and then when you close it, you have the servo close that latch. So you have this servo kind of spin something over and it latches into this plate and holds this shut. And then whenever you're ready to climb, you release something from the servo. It basically like unlatches and that whole door opens up because it's sprung open, would be my guess as to how that's going to work. I don't know exactly where the springs are going to be tied into. They could be big enough torsion springs like on this shaft. They could have like elastic somewhere wrapping around. Or pulling behind the pivot somewhere. There's a lot of ways to do that same thing, but that's a pretty simple way to get the backside of the robot fully open to allow the chain to come through without being able to touch the anchor, which is one of the bigger challenges for a lot of teams where just everything's trying to share space and you need to be able to clear out that room for the climb to happen. Okay, looking at the climb itself, I don't know if that's going to actually fold out right now. It doesn't look like it does in their CAD, but that's fine. The basic idea is they have a climber arm and latch system that is similar concept to the EveryBot climb, where this goes between the cage pulls and then latches back into this gap. So these can fold in. Oh, yeah, look, these fold in, that's cool. So these fold in as the cage comes through, and then they push back out once they're past the cage. And these constant force springs are always trying to pull them out. So these are going to be tied up to somewhere, always trying to pull them back out to this position. And the force of the robot in the cage is going to push them in. And so now your cage bars are locked in here. You have this big funnel plate that gives your driver a pretty big hit box to drive into the cage. And so you'll see a good number of teams with that funnel or wedges or whatever you want to call it to align them to the cage. So this whole thing would be flipped out to do that and out over their bumper. It looks like, yeah, so it's just like a strap here that's winched in. So as they unspool this, this would open up. This is pushed forward by this gas spring right here. So you have a gas spring connected to this plate and then connected to the tube itself. So this is always trying to push it forward. The motor is holding it back most of the match while it's wound in. And then it pushes it all the way forward. While it's pushing that forward, it's also, zoomed out, all right. It's also going to push this arm forward. And so this arm is basically going to act like their foot. So this little roller is going to kind of roll up onto the bottom of the cage, either as the cage is being pulled in or as they're driving in. And then this bar is going to help straighten out the cage so it keeps it from wanting to rotate away or rotate out of the latch. So that should stop it from only like latching on one side. I imagine that bar helps with that so that it's latching on both sides of the latch, so the cage will actually be flat to the robot when they want it to be. This bar is held up to this by another constant force spring in here. So this gets unraveled and gets bolted or riveted into one of these holes so that it's always wanting to be pulled as close to this thing as it can get it. This bar, this plate right here runs into this standoff, so it can't go any further than this. So this is basically its stationary state. The spring is always kind of holding this up. When they're driving around most of the match, this is all folded in, tucked in nicely, not getting run into, not shaking out or vibrating or anything else. And then once this fully deploys, we have a little cam down here basically and a catch. So when this is rotating, eventually this flat will rotate past this one, and then those will be locked so that it can't come back up. So this will push all the way down. These little arms here are sprung up. So this is always trying to push up into this black piece. And the constant force spring, the torsion spring here is what's doing that. So it's always trying to push up. And so as soon as that latch comes around, this is able to push up, grab this, basically, make this go past it. And now that black part, once it's fully down, has to stay down for the rest of the match. And that's going to hold the bottom of the cage down and allow their actual climber arm to pivot it a lot sooner and prevent the cage from like riding up or the chain from going into their elevator or anything like that. So that gives them a nice known location for the bottom of the cage. They know where they're going to grab towards the top of the cage, and they can pull it back in and get a very secure shallow climb it'll probably end up something like that, right, where the chain is going out this way. This wheel is going to be a little bit closer to the ground, probably. I don't know if it's going to be exactly level. And so then you'll have a full climb off the shallow cage. You'll get the points and secure an RP in most every match. You can do that as long as one of your partner parks. Cool. Let's see. Any other details? So they're doing a pretty similar drivetrain setup to us, where we basically have that 3-inch drop to the belly pan, just using 1x1. We do the same thing, but they're doing most of their electrical is going to be in a what's often called a brain pan, because it's at the top of the frame instead of the bottom. And so they have this polycarb cover here, and then a lot of the electronics will be underneath this, wired under it. And so then their elevator mounts on top of all of that, instead of kind of in, down, lower to the floor as well if they needed to. But the other side goes the other way, and their battery is on a belly pan, so sink it a little bit lower into the ground as well. Everything else seems pretty normal. Some A-frame supports for their elevator, getting it triangulated a little bit. Nothing else seems too out of the ordinary. I think that's everything. Cool. All right, we can go on to StuyPulse, I think. This is going to be this seems like it's going to be a pretty good version of this type of robot. We're going to see a good number of them that have the funnel on the back that feeds into some sort of scoring mechanism on their elevator. We're also going to see several teams who do something along these lines where the coral and algae are shifted off of each other, so that while they're taking algae or scoring coral, they're kind of already aligned because they have that bit of an offset. I don't know exactly what that offset distance to center is. It's kind of hard to find on here probably to get exact center. But we can get some idea. That's like 3. If you add 2 1/4, yeah, they're pretty close to like 6 inches from like center of here to the center of coral. If they're 6 1/2, it's exactly where if they're scoring here, they're in the same spot for algae. If they're on the right branch, but it should be pretty close either way. It looks about 6. So there's gonna be a good number of teams having some sort of setup that way to make that work. All right, let's move over to StuyPulse. They have a lot going on in this robot. All right, I guess we can start at the bottom. Relatively normal drivetrain using one of the West Coast Products swerve drives. Yeah, it's the Swerve X2. So they are the Swerve X2 inverted, so their motors are kind of pointing down. The non-inverted modules have the motor, the back of the motor is pointing down. The non-inverted modules have like the motor mounted up here and the motor sticking up. Let's see, then they have a pretty standard belly pan, lots of lightning holes and things, kind of around their climber that's going to be in the middle that we'll talk about in just a second. And then also kind of around their elevator, so they fully cut out parts of their belly pan to allow easier access to the bottom of their elevator, which is pretty nice. We learned recently that we didn't do that and probably should have. It'll be interesting, like we'll have some potential issues getting belts and stuff. If anything gets stuck down here, we know it's going to be a potential problem for us. We're mitigating that with some other things that we're doing during assembly to make sure that we can like pull these plates off if we need to quickly to get something out. But yeah, so they are running a belted elevator. We can start seeing some of that now. They have motor gear, and then the 2 gears here, and then the pulley. So this is going to be pretty similar elevator to what we are doing as well, where they have the belts running internal to that elevator frame, or internal to the elevator rails here. Looking at kind of like the high overview of a robot like this, we have swerve drive, we have some sort of intake out on this side. So this is going to intake algae and coral. So when you have those two rollers about 4 inches apart, you can probably guess that it's going to intake coral. It's doing the similar setting or a centering concept to us as well. So it has the little bump outs here that let the coral not actually go in here, but let it actually kind of center as it's driving through. And then the algae will be able to come in under and get stowed up on some of these bars here so that they're able to put it into the processor. And the coral can get lifted up and scored into level 1. We're going to see a good number of teams doing this, I think. So since so many teams are ejecting coral for level 2 through 4, kind of straight out and just ejecting it and don't have any way to twist it or turn it, like our robot concept does where we twist the wrist. If you have another mechanism that can get coral the long way and then score it onto level 1 that direction, it works very well it works very well too, or that's at least the idea. We'll see when actually the gameplay happens. So this is one of the robots that actually inspired us to kind of change some of what we were doing and get all the way to where we are now with the double ground intake and climber all built into one mechanism, as they were able to pretty efficiently build their coral ground intake and algae ground intake into a single mechanism. It also has, for the coral side, they have a funnel as well. It's also about half the robot. You can see how wide theirs is. So they're going a little under 19 inches of width, so that's probably close to 5 times the width of the coral, somewhere in there. And so it's also powered, but it's powered on the side. So you'll see several different variations of how powered funnels can work. They have belts on the side, so if the coral comes in and gets kind of jammed in, or if you put it in like long ways, this belt is going to help like redirect it, this end of it down and into their actual end effector. And so there's several different versions where you either have belts on the side, maybe both sides, belts on the bottom. Some teams have put wheels on top. There's all sorts of different ways you can have a funnel mechanism and get it powered to try to clear any jams and just be super efficient coming from the human station and getting coral down into place to be able to score it on the reef. Lots of different polycarb covers. It doesn't seem like it'll be too easy for coral to get caught anywhere, so it's not going to get it falling in. If it does fall, it's going to kind of glance off, which is what you want in most places. Let's see. Yeah, they have electrical down here, so they got their PDH vertical since they lost some belly pan room due to how their climber is going to work. So they have their Robo Rio and Carnivore up here. And so vertical mounting electrical definitely works. It's pretty easy. It actually is a little nice because you get less dust and debris stays in it since gravity is working against it to want to fall down, which is good, where when we lay all of our stuff on the belly pan, any aluminum chips or anything else want to fall into the electrical and stay there, which is one of the annoying parts about it. Let's see. They're looking like they're going to use some amount of max composite or just polycarb because they put the little graphic on it. So that may just be for CAD. It may be for real. It looks like they have it out here too. Let's see. Yeah, lots of little polycarbonate panels to help like guide the cage as we're about to start talking about the climb. We can look at their elevator and end effector first before we get to endgame. All right, let's see. Does everything move in here? Yes. Cool. All right. Elevator moves and arm moves. Let's see. Can I get it all the way back down? All right. So coral comes through the funnel, is going to go into the arm here. And then depending on how everything works, it's possible that they can like raise up and just score level 2 with their elevator and not really moving their arm very much. They also might flip around for some of it. So depending if they want to like reach out further, they probably do for some things. So for some things, they may be reaching out and scoring out the back of the mechanism. So there's quite a few teams doing that. It kind of just depends on as teams figure out what works the best. Doesn't want to not move. OK. So as teams figure out what works, why does the arm come down? That's annoying. All right, let's see. Let me. Okay. I know what I can do. Before we get to elevator, I'm just going. Oh, I can't lock the elevator from here. All right, that's fine. We'll make it work. Yeah, so you should be able to have the arm come up and score kind of out of the backside there. If it wants to move, it doesn't. All right, while that's talking, we can talk about the other bits of this. So they have the outer two wheels all driven what looks like off the same belt that is driving the rest of the coral rollers. So they have this one long double-sided belt. And so that's what's giving them the one direction here, a reverse direction for these top wheels here, and the same direction as these lower ones for these green wheels. And so this belt path has some idlers, but mostly just running around the 4 or the 5 wheel shafts that it needs. And so those are all spinning the same direction. And then you have this idler shaft back here that's getting powered by a motor that appears to be way up here at the other end of their arm. So you get motor, belt to pulley. You get these printed double pulleys. We've done that before, so you get a nice reduction. And everything can be made in like one print here. So that motor is what's going to drive all of the wheels down here. They keep the weight of their motors back behind the arm, so they are getting a little bit of counterbalance here. So as the arm rotates up, these motors are kind of helping, gravity's trying to pull them down this way, which counterbalances the weight of this a little bit. So it's definitely better not to have the motors all the way out at the end of your arm. Same reason why we are doing something similar with our design. And then these wheels work with the little semicircle back here to hold algae. So algae will get sucked into here. And they'll be able to flip the arm all the way up with the elevator and score algae out this way into the net, and then level 4 coral out this way. Similarly, they'll be able to come in and score level 3 coral and probably level 2 in some configuration as well. Looking at their pivot, so one of the things they did that's kind of unique is they have this max spline pivot here, or actually not max spline. This is Spline XL, which is the West Coast Products equivalent large spline shaft. And so this spline shaft is actually not going to rotate at all. So this is going to be stationary. So it has the collar back here that's clamping it. And I imagine that's going to be bolted through into this plate. And so this shaft is basically acting like a dead axle. So they're not spinning this to actually spin the arm. They are just going to have bearings in their actual arm plate, which you can see here. So a bearing like that. And over on the other side, somewhere in there. And so now you have your bearings here. And so that's what the arm is going to spin on. And so the motor then that's actually spinning the arm is this one. So the motor that's actually doing all the arm movement is on the arm itself. And so it has a little gearbox here. So you get one reduction to a sprocket that's under this chain, out to this much larger sprocket here that is, again, stationary to their elevator. So all of these standoffs are holding this sprocket in place, and this motor is basically driving this sprocket around that big sprocket. And so the motor is moving itself in a big circle around this stationary sprocket, which is pretty cool. The other part of this that I just saw is, so this chain run's pretty small, but you still will end up eventually getting it kind of loose. So depending on exactly how you calculate the chain distance and stuff, eventually this will get a little loose. and it might either cause backlash or even the chain could eventually skip off. So you want to have some way to tension the chain. And so that's what they do here with this other sprocket and this cam setup where they have double cams in CAD, but this is mostly just like the different positions of it. You'd have a bolt going through here, and as you turn this cam and then tighten it, it's pushing on this plate that this sprocket is spinning on. This sprocket pushes into the chain, and that's what holds your tension. So this is one way to do tensioning. A lot of the things that are currently on our robot, we're planning to use ratchets for that, to where we can just push with the ratchet and have it hold tension. If for some reason those ratchets end up not working, it's very possible we end up in a very similar situation to what they're doing, and we'll use some of these cams. West Coast Product sells them. I think ThriftyBot sells a version 2, or at least did. And you can push that, and you can apply tension to that chain to keep it nice and tight and remove any backlash, so that when the motor moves, the arm moves immediately, and you can't move the arm without moving the motor, right? That's what we mean when we're talking about backlash, is just any amount of motion that the mechanism can do without the motor actually moving. So any little bit of play or anything like that is what we mean by backlash. Okay. We can look at their elevator pulley stuff. So they went ahead and machined the tubes for their elevator. And so instead of what we did, where we used some plates basically between the tubes, so we basically like cut our elevator tube here and have a little connecting plate that holds this pulley on, and then holds our elevator blocks that kind of mount on the side. They are using the what looks like the standard kind of West Coast Products elevator blocks, which we used last year for our amp mechanism, and worked very well. And so those mount to the face, and then they machined the 2x1 to be able to have a window here to be able to put the idler through, and then also this little plate and hole to be able to have the idler run through here as well. So that's where the belt's going to run over and down to be able to actually lift and move the elevator and everything. Can I get the elevator tube back? Come back. There it goes. Okay. Let's see. How are they doing belt tension? Have we seen that yet? Let's see. So right here. So they have another one of those cams, and so they'll clamp the belt into here, which is what I was guessing was going to happen. And so they have this machine part or printed part, depending on how they want to do that. I don't know if it's going to say anything in here. Probably not. Yeah, it just says it's the clamp. Yeah, we don't know. But printed would probably work. Machined would also work. And so that clamps the belt. And as they tighten those, as they turn this cam and then tighten these 4 bolts, they can tension the belt. Wait, how does that work? Hold on. So that's going to push down. Oh, no. Okay, so the cam's running the other way. It's just in this model, it's weird. The cam's going to push up on this point of this cutout right now. And so that basically this whole block is going to be pulling up on that belt to provide tension. And so they can do that on both sides. And then we can, I want to be able to come in and see. Yeah, so then they can come in and do that. And then the other side of their belt has to get tied off somewhere. Where does that happen? So that's going to be, so they're tensioning on the down pull. No, maybe. No, that's going around. So they have another idler here. So that is the up. So that is going to be the up. So the up comes in through there. And so I don't know where the down gets tied off. Oh, there it is. So down's going to get tied off here. So they have another belt clamp here. And so that's where the down pulling belt is going to get tied to, like so. And then their up is going to come around and get pulled in like that. So they're basically pulling up across this pulley right here, or idler pulley. This won't actually be rotating most of the time during the match. This should be, the belt should always just be staying attached here. And the belt that's running up along here is just going to get shorter and shorter until it runs over this pulley. And then this is what runs down the other side. And as you pull down here, the whole elevator goes up. So you have lots of little custom elevator gussets, some hard stops. So this thing that sticks out is going to run into something else up top, this guy, to set it to where the end stop is so their elevator doesn't go too far. Let's see, we can see how much bearing overlap they have. They have 5 inches, so they have like an inch short on their hard stop compared to where we currently are. So what that means is it's possible that maybe if we needed to, we could potentially get like 1 extra inch of elevator if we wanted on our range. We could test that if we end up needing it. We don't think we do right now. So ours basically just stops like right there, and theirs can come up a little bit higher right now. But those are things that are pretty easy to play with. It's very possible that they could just like move this block down a little bit, and then they would also have 6 inches if they decide they don't need that extra height. So all of those things are pretty easy to change for any of the elevators. Let's see. Their bumper solution looks pretty similar to quite a few teams over the years. So I think 971 in 2019 was one of the first teams that I know of to do it, where you basically make this plate that has like the semicircle hole in it. Your bumpers have a stud, so this is like a bolt that you can buy these on McMaster-Carr. They go through the bumper back bracket, whatever it is, plywood, whatever it is. You can screw it in, and then this kind of just slides in. And when you turn a wing nut or a normal nut or whatever into here, tightened onto like a washer, this holds it, and then if it tries to lift up, it can't because this washer runs into the rest of the circle. So the bolt itself can slide in, but then once you tighten it down, it's secure and the bumpers can't come off. Maybe. No, I can't get the bumpers back, but that's fine. Let's see. I think that's most everything. Oh, we didn't talk about climb. That's right. I kept alluding to climb, and then we never talked about climb. So they're doing what a lot of people are calling the donut climb, something along those lines, belly pan climb. And so basically what will happen is their elevator and arm will move out of the way, and they'll determine what out of the way is, same with their intake. And they'll be able to drive into the cage, and they have these 2 kind of wings here. And so the cage will come in. These bars, if I can get them to get back to their normal location, will be, rotate. All right, they don't want to rotate all the way. Okay, at some point these will be flat, but the CAD doesn't want to do that. So you can imagine like this down here will be down into like that gap basically. It'll fold through this like red polycarb. And then same with that gray one, it'll go the other way too. The cage will come in and basically get stopped by this bar here. And then they have a motor on a Max Planetary with a chain mounted to here that's going to spin this shaft. Let's see, how does the next one work? Is that inside? Oh no, there's another gear here. And then there's another gear on this shaft that isn't shown, or I hit it at some point, or it's just not shown. And so it'll drive this gear. That'll drive a sprocket to this other shaft. And so then once the cage is in, they'll be able to push down on these it will drive onto the bottom of the cage, that bottom plate, and it'll push all the way through. I don't know if it's going to let me go all the way through. But it'll push all the way through at some point. I don't know why it doesn't now want to let me do that. I think it did at one point, because I was looking at this a while ago and it did. But it'll push all the way down, and they will be fully off the ground, supported by these two plates, with these basically sitting on the top of the bottom of the cage, and they'll lift their wheels a little less than 2 inches off the floor. That'll keep their bumpers within the bumper zone. So your bumper zone, you have to have at least the space between 2.5 inches and some number higher than that, 5 something, filled with bumper and filled with padding. And so they're still able to do that even while these are going to the ground. And so I did that. The wheels will be much higher off the floor. These will push 2 inches from the top of the cage. The top of the cage is closer to 4 inches off the floor, because the bottom of the cage is 3, so the top of the cage is somewhere around 4. And then they have another 2 inches there. So their wheels will be closer to like 5 or 6 inches off the floor, most likely. And so they should have plenty of height for actually getting the deep, or the deep cage climb. I think I said shallow earlier on the other robot. They're both deep. They are getting the lower cage, the one that has all the points attached to it, and the RP, to be able to get it fully climbed. So we'll see a few more teams doing this. There's at least a few other Open Alliance teams doing some style of open bottom climbing, where you don't have to tilt the cage at all. It does just mean that you end up with a lot more room in your robot dedicated to the climb, because you can't easily just put your electronics on the belly pan or anything, so you just are using belly pan room for climb. But as long as you can move those out of the way like they did, it's a very valid and reasonable solution for how to play all the aspects of the game. Okay. I think that's all I have about the robots. They do have their cameras set up here, so you can see like Limelight's, looks like Limelight 4, pointed one way, then another one over here on the back. And so this is the full field of view of the Limelight as well, so they can see where the what the Limelight can see. This is one of the things we haven't really played with enough yet, so this is on our list of things to do to see where we can mount our cameras for best positioning. That's one of the things we still have left to do as we're finishing up a lot of the CAD and design for our robot. All right, I think that's it for tonight.